So I get 3x squared plus, use the product rule, don't forget the product rule. 2 times the derivative of x is 1, so 2 times y, plus 2x times y prime equals 0. Okay. Algebraically, you solve for y prime, so subtract these two, divide by 2x. So there's the derivative. And then you were asked to find the derivative at x equals 1, so you plug in a 1, you start plugging in, you say, oops, there's a y in there. So then what do you have to do? Go back to the original equation and plug in an x equals 1 and solve for y. So then I solve for y, then put that in with the y and work out slope at x equals 1. Okay? Any questions on that? All right, so let's get the test back. Hang on, huh?
Kiefer, do you want me to go out? Yeah, you do.
Not until we start discussing. Not until we discuss.
Hi, Dorado. It was fine. Like, I got 3.
Well, the thing is,
next week. I love it. 34. Got it.
Oh no.
I did not
Yeah. Sure. Yep. I will stick it right up here a little bit, and so from that room you can just get started on it.
It probably just wasn't what I did.
I got wise worthless
I didn't get last.
Alright, the test said 48 points, score question, I lowered it to 43. So, I got 165 total. And
Oh, not fair.
okay, why don't the three of you that haven't taken it step out for about 5 minutes? I'm just going to make a couple of quick comments.
Yeah, right? Wow.
Okay.
Oh, can you put that back up there?
All right, any questions on the first 8?
That's not the first one.
That sounds like my basic skills class. All right. Okay? All right. Number 9, I'm just going to give the hint. Basically, you have a curve that goes from 0 to 1, and it's revolved around, and you're supposed to figure out the surface area. Okay? So you have to figure out the length of the arc, and then revolve that a distance of 2 pi r. All right? So the surface area is going to be the integral that goes from 0 to 1. The length of the arc, which is what? Square root of 1 plus the derivative squared times the radius, 2 pi times r. 2 pi times the radius. So this would be the radius. Okay? So that's the concept. Now, what a lot of you did is you found 2 times pi and you took the radius and you revolved it around and let that be the surface area. You were just finding a bunch of you were basically revolving this around and finding the surface area of all of these. Makes sense, right? Except that's not the surface area because the surface area is slanted. Alright? And you may say, well, when I get these really, really tiny, it doesn't matter, but it does. Because let's take a picture of this one of these discs that you're revolving. When you revolve a disc, you're revolving a disc that's like that. And you're figuring out this area as it goes around, right? Okay, but you should be finding the length here. So that little part there is longer than this. Okay, so that's why you can't just take the radius, 2 pi times the radius, and revolve that around, because then you're just finding the horizontal surface area. For example, if this was a ratio of 2 to 3, it doesn't matter how skinny you make the disc. What's this ratio going to be of this horizontal surface to the slanted surface? It's always going to be a 2 to 3 ratio. So to find the surface area, you have to find the length of the arc and revolve that, not just find the edge. Okay? There were a few of you that did it and got it set up good. Not too many did it by hand, but I'm not going to do it by hand right now. I'm going to move on to other things, but at some point I'll come back and do it by hand.
How many points does the whole question?
4. So I only hit you a couple, I think. Okay? Number 10. It says find the length of the curve. Well, what if y is 9 minus x to the 2/3 to the 3/2? What is the derivative? Because you're going to need the derivative to find the length of the curve. So what's the derivative? 3/2. 9 minus x to the 2/3 to the 1/2 times a negative 2/3 x to the negative 1/3. Chain rule. Okay? Now let's clean that up. The 3/2 and the 2/3 are going to cancel. We're going to have a negative square root on top. And we're going to have a x to the 1/3 on the bottom. Okay? That's the derivative. Now, what is the length of the curve? The length of the curve is the integral that goes from 1 to 8, the square root of 1 plus the derivative, what? Squared. So we're going to square this mess. What's this mess squared? It's going to be 9 minus x to the 2/3 over x to the 2/3. Because you square the top, it just gets rid of the square root. You square the bottom, it becomes 2/3. Okay? Dx. All right, what do you do when you add fractions? Get a common denominator. What's the common denominator? X to the 2/3. So this now becomes x to the 2/3 plus 9 minus x to the 2/3 all over x to the 2/3. All right? What happens? The x and the 2/3 cancel out, and you're basically taking the square root of 9 over x to the 2/3, which is 3, and the square root of x to the 2/3 is x to the 1/3. So there's your integral.
Oh my gosh.
3x to the minus 1/3. That's what you're evaluating.
Can you teach us
You can do it neither?
What?
What'd you
I
say?
can do it. Well,
Okay.
just saying, like, if you didn't put the x to the 2/3 on the bottom, you could have multiplied it with the 9 minus x to the 2/3 and just got 9 to the negative 2/3 minus 1.
If you had multiplied this
Yeah.
by top and bottom by that?
Well, like, after you square it.
Oh, after you square it.
Yeah.
Oh, okay.
So it's less than.
Yeah. All right. Now, will you have to do algebraic manipulating like that in the AP test? No, you won't. You're not. But you're going in college. There's going to be professors that are going to want you to be able to algebraically do things, and you should be able to see them happening. They're not. Something like that won't be on the AP, so don't panic on that. All right. Any others? Oh, you wanted 12 then too? Okay. 12. Okay, there is the function for x. Find its length that goes from 1 to 5. All right, so the length from 1 to 5 would be the square root of 1 plus x prime squared, right? Because we're doing it with respect to y. So we need to find out the derivative of x with respect to y. What's the derivative of x with respect to y? It's this y plugged into here, so it's 9y squared plus 6y. And it's the square root. Okay? So now, the length of the curve is 1 to 5, the square root of 1 plus the derivative squared. So if this thing is squared, what happens to the square root sign? It goes away. You get 9y squared plus 6y. And if it says if it can be done analytically, this thing must be able to simplify. You can't do that by hand if it doesn't simplify. And what is that thing inside there? It's basically 3y plus 1 quantity squared. It's just 9y squared plus 6y plus 1 factor.
What was I doing?
And so now you're integrating 3y plus 1.
Why can't you just take the derivative of like the 1 plus 9y squared plus 6y?
Derivative of this?
No, or the antiderivative, sorry.
But see, the function x is an integral. You can't take the derivative of this because you're taking the derivative of the integral, which means you just plug y in for the function.
No, I did that much, but I'm confused as to why you factored out the 1 plus 9y.
Why can't you integrate this?
Yeah.
That's a mess. I mean, because you're taking a square root of something squared plus something plus 1. Yeah. Because see, this thing simplifies down to just 3y plus 1 squared. You take the square root of it, you just do the number 3y plus 1.
What's anti-differentiation?
What?
Anti-differentiation.
Where are you at?
It's just, it said find the exact length analytically by anti-differentiation.
That means, you know, take the antiderivative of this. Don't plug it in your calculator. But I gave credit even if you got the right answer. Push in that one. Okay? And I can show you later because you can't just say it's. You can't.
No, I did it now.
Okay. All right. Okay. Any others? 14. All right. This is the one where you. What are you doing? Filling the tank or emptying it? You got to empty it. Okay. And so the tank is up to a height of 9. This is 3 feet, so this is 12. What we're going to do is take a bunch of discs and lift them out. So, the work done.
Wait, how do you know that you need to dump it out?
Well, you're lifting it to the top of the surface, the top of the thing. So essentially, you're taking all these discs and you're lifting them out a certain distance.
But that's not really dumping.
What?
I
It didn't say dumping.
But
It says pumping.
What? Oh, I'm hoping that's. Yeah, sorry. I thought you said
Okay.
dumping, and I was like, wait, what? Sorry.
All right, so the force is the weight of each disk, so it's going to be pi r squared times its thickness times its density, okay, times the distance that you have to move. So the bottom disk has to be moved 12 feet, this disk here has to be moved 3 feet. Okay, we all right in the concept? Now we got to put it into an integral. So the integral is, well, let's go with radius. That's easy because it stays constant. What is it? 6. What's the thickness of each disk? D1. So that can go over there. What's the density? 64? Yeah, times 64. Now, how far does it have to move? Well, it depends on what you put here. How many chose to go from 0 to 9? Well, if you chose from 0 to 9, then what does this have to be? 12 minus y in this case. Because then when you put a 0 in, the rate, you're down here at the bottom, that has to go a distance of 12, which is right. If you put a 9 in, then it has to go a distance of 3. Okay? If you had chosen 3 to 12, then instead of 12 minus y, it would have been just a y. Okay? These two things and that have to coordinate so that the disk is moving the correct distance. Okay? All right. Well, that wasn't a good enough explanation or too fast. I can walk through it a lot much slower. Now, which one's 11? That was totally a calculator one. So, you should have just said the length is from, oh, but we do have a problem. And what is the problem?
It's not.
When you take the derivative of this, you get 2/5 x to the negative 3/5, which means the derivative is in the denominator, and you're going from negative 1 to 1, you're going to get something undefined. So then what did you do?
Multiply half of it by 2.
Yeah, integrated from negative 1 to 0, and then integrated from 0 to 1.
Or multiply negative 1 to 0 plus 2.
Yeah, or just multiply it by 2. Yeah. Okay. And then, if you still run into trouble because you're plugging the 0, then just put in 0.00000001 to get your decimal answer. You know, if the calculator is still giving you an error. Yeah. If it was giving you an error, then just put in some number really, really close to 0. Okay? All right. All right. What's that?
Oh, I forgot to write down one of my scores. Okay, it's like all
All
time high.
Booked up.
Really good. Mine needs a little bit of.
Okay, the next topic. We're actually going to go back to chapter 2 now and find limits. And what's going to help us with finding limits is a new theorem called L'Hopital's rule. If you look over there at the 4 examples I put, and you try to figure out the limit of each one, you plug a 0 in, you get 0 on top, you get 0 on the bottom. You plug 0 on the top, 0 on the bottom. If you plug infinity to this one, you get infinity on top, infinity on the bottom. And plug in a 3, you're going to get 0 over 0.
Well, why do we need to know the other way if there's a faster way? It's actually like
Those are called indeterminate forms. You can't determine the answer based on that form, because each one of those are going to have different limits. And yet, when you plug in 0 at this point, you're just getting 0 over 0 or infinity over infinity. So they're called indeterminate forms. We know how to do some of these. This one here, what could you do before you plug the 0 in? Cancel out the x's, and you get the limit as x approaches 0 of 5, which gives you a limit equal to 5. This one here, you could cancel out the x's, and you get an answer equals 3. What could you do with the next one? Well, before L'Hopital's rule, what could you do? You could divide top and bottom by x, and if you divided the top by x, it would leave you with x plus 1 over x, and divide the bottom by x, it would leave you with 1, because x divided by x. Divide top and bottom by the same number. Now what happens if you put infinity in? You get infinity plus 0, that's still infinity, divided by 1, you get infinity. Alright, this one here, if you did a little algebraic manipulating, you could multiply top and bottom by the square root of x minus 3. And then that would give you x minus 3 on top, square root of x minus the square root of 3 on top. And on the bottom, it would give you, oops, I'm sorry. I wanted to go by plus. Sorry. Multiply top and bottom by the opposite sign, because what happens now? The middle term will cancel out, and so you'll get an x, no middle term, and then a minus 3. Which then allows you to cancel the x minus 3's. And now you're finding the square root of x plus the square root of 3, which would give you 2 square roots of 3. Okay? Alright, so we were able to solve those. The first two were really easy. Next one, just a little manipulating the x. The fourth one, a little more algebraic applications. What do you do if it's not quite so easy? There's got to be some other way of finding the limit of an indeterminate form, and it happens to be L'Hopital's rule. So let's let f of a equals 0 and g of a equals 0, and figure out what is the limit as x approaches a of f of x over g of x. Well, what is f prime of x? What's the way of writing f prime of x? See if you can dig in a memory box. It's the limit as x approaches a of f of x minus f of a over x minus a. That was there's two definitions. One involved h's and then the other involved letters like this. What's g prime? The limit as x approaches a of g of x minus g of a for x minus a. So now let's put this information together, right here, and write the limit as x approaches a. I'm going to put f prime on top and g prime on the bottom. Well, that's going to give me f of the limit as x approaches a of f of x minus f of a over x minus a divided by g of x minus g of a over x minus a. All right. Algebraically, what can we do with that? Cancel out the x minus a's, and so it gives me the limit as x approaches a of f of x minus f of a over g of x minus g of a. But what did we say at the very beginning that f of a and g of a equal? They equal 0. So this is 0, that's 0, and it gives us the limit as x approaches a of f of x over g of x. All right, now what did that just tell us? It just told us that the limit of a function over a function equals the limit of the derivative over the derivative if this equals 0 over 0. Because if you plug in an a, you're going to get f of a. You can plug in an a, you're going to get g of a. If you get 0 over 0, you get the same answer as if you take the derivative. So L'Hopital's rule says to find the limit of a function divided by a function, if it gives you 0 over 0, simply take the derivative of each function, and it'll give you the same limit. Okay, so let's do some examples.
Does that work for infinity too?
Yes, it works for infinity because infinity over infinity is really, what do I want to say here? Is 1 divided by 0, 1 divided by 0, which would be 1 divided by 0 times 0 divided by 1, which is really 0 over 0. So infinity over infinity gives you the same concept as 0 over 0 does. Okay? All right. So let's find the limit as x approaches 0 of the square root of 1 plus x minus 1 over x. All right, so the first thing you do when you have a limit is you plug in the number and see if you get an answer. Because if you get an answer, you're done. You don't have to do anything fancy. You just plug it in. Well, what happens if you plug a 0 in? you're going to get the square root of 1 minus 1 on top. You're going to get 0. You're going to get 0 over 0. If you get 0 over 0, it's an indeterminate form, which means you can use L'Hopital's rule to find the limit. So, L'Hopital's rule says, find the limit of the derivative of each of these. Don't use the quotient rule, but the derivative of each. So this is really, think of this as 1 plus x to the 1/2. So what's the derivative of that? I might even fall asleep. 1/2. 1 plus x to the negative 1/2, and then minus 0, because the derivative is 1 is 0. And the derivative of x, the denominator, is 1. Pardon me?
Why is it minus 0?
I'm taking the derivative of this top expression. Derivative of 1 is 0. It's a constant. And so now plug in a 0.
Don't you have to do the chain rule for the inside, which is just all
Which
times
one?
1?
Which one? So now I plug a 0 in, and I get 1/2, 1 plus 0 to the minus 1/2, divided by 1, gives me an answer of 1/2. So it's a limit approaching 1/2. All right. Okay. Now, in addition to those two indeterminate forms, you also have the following. Infinity times 0, infinity minus infinity, 1 to infinity, 0 to 0, and infinity to 0, as far as taking limits. So L'Hopital's rule only works for these two. So if you come up with something that's in one of these forms, you must put it into that form to use L'Hopital's rule. That's my next example. So find the limit as x approaches infinity of x times the sine of 1 over x. All right, what's the first thing you do? Plug it in, see what you get. See what you're dealing with. So plug in infinity, and you get infinity times, what's the sine of 1 over infinity? It's basically the sine of 0. What's the sine of 0? 0. All right? That's an indeterminate form. You can't tell. Is it going to infinity faster, or is it going to 0 faster? If it's going to infinity fast, then the answer is going to be infinity. But if it's going to 0 faster, it could be 0, or it could be anywhere in between. All right, so what you have to do is rearrange it so it's in this form. How can we rewrite this so it looks like a fraction, something over something? I'll give you a hint. I'll put sine of x, 1 over x on top. What am I going to have to put on the bottom so it gives me the same answer?
Sine of x.
No. X to the negative 1 or 1 over x, right? If you bring the x down here, it becomes x to the negative 1, and x to the negative 1 is 1 over x. This says the same thing. All right? Now plug in infinity. What do you get? Sine of 1 over infinity is 0. 1 over infinity is 0. So now it's in the correct indeterminate form, so you can L'Hopital's rule to figure out the limit of the original. So L'Hopital's rule says, take this thing here, take the derivative of the top, take the derivative of the bottom. Not the quotient rule, just the derivative separately. So what's the derivative of the top? Kareem will make you work on this one. It's the derivative of sine.
Cool side.
Okay. But now you do have to take the derivative of what's inside because there's a 1 over x. What's the derivative of that?
Natural.
No.
Negative 1 over
Negative 1 over x squared. So that's the derivative of the top. Now, what's the derivative of the bottom? Derivative of 1 over x is negative 1 over x squared. So now, fortunately, before you find the limit, what can you do? You can cancel out these two terms here. And then we're finding the cosine of 1 over x, which would be the cosine of 1 over infinity, which is the cosine of 0. And what's the cosine of 0? 1. So this particular limit is approaching 1. Even though it's infinity times 0, it's approaching it at a speed that it ends up being at 1. All right, one more example. Actually, I got tons more, but you only need one more to.
Wait, why is 1 over infinity 0?
What's that?
Why is 1 over infinity 0?
You take 1 divided by infinity, it's approaching 0.
Oh, yes.
With any constant divided by infinity. All right. What is the limit? As x approaches 1, of 1 over the natural log of x is 1 over x minus 1. Okay, so what should you do first? Plug it in, see what we're dealing with. So if you plug in a 1,